Do you think metal recycling is a perfect solution? Do you believe it helps protect the environment, save resources, and reduce pollution? But is the truth really that simple? Today we will uncover the lesser-known realities of metal recycling, the dark side of an industry that seems green and clean, but is in fact full of contradiction. In theory, metal recycling is a perfect process. It helps reduce resource extraction, save energy, and minimize environmental pollution. Imagine an old aluminum can being melted down and transformed into a new one. It sounds ideal, doesn't it? But did you know? Things aren't as perfect as they seem. Behind this process lie issues that few people talk about. The truth is, not all metals can be recycled indefinitely. Aluminum, copper, and many other metals gradually lose quality after each recycling cycle. Every time they are melted down, a portion of the metal oxidizes and turns into waste that can no longer be reused. We often think recycling reduces pollution, but in reality, the opposite can be true. Recycling plants still emit CO2, metal dust, and even toxic chemicals like dioxins and fluorides. And when metals are not properly sorted, they can react with each other, forming even more hazardous compounds. Did you know? Not all recycled metals are as good as pure metals. In the construction industry, for example, using recycled steel with high impurity levels can weaken the durability of structures. A bridge or building that relies too much on recycled steel may not meet safety standards, increasing the risk of collapse. Even in the electronics industry, recycled copper often contains more impurities than pure copper, reducing its conductivity. This leads to less stable electronic components that are more prone to malfunction. What's more, many recycled metals must be mixed with virgin metals to meet quality standards. This means that no matter how much we recycle, we can never completely eliminate the need for new resource extraction. Think about the recycling workers, those who face daily risks. They are exposed to lead, mercury, and cadmium, substances that can cause cancer, nerve damage, and respiratory diseases. Not only do they come into direct contact with these toxins, but airborne metal dust can also lead to chronic lung conditions and weaken the immune system if inhaled over time. Even more alarming, in many developing countries, the metal recycling industry generates massive profits for business owners. Yet in pursuit of higher earnings, many of them cut corners on worker safety. Providing protective gear or investing in hazardous waste treatment systems is costly, so most workers operate without any safety measures. They handle metal waste with their bare hands, inhale toxic fumes from melting processes, and remain unaware that they are slowly facing a painful and premature death. But it's not just humans who suffer. The environment is being destroyed every day. Metal waste mixed with industrial chemicals is dumped directly into rivers, contaminating drinking water for millions. The soil becomes poisoned, preventing plants from growing and disrupting ecosystems. Heavy metals like lead and mercury accumulate in the soil and water, poisoning animals and humans through the food chain. This means not only the workers in recycling plants, but also the surrounding communities, and ultimately all of humanity are affected, as we all share the same atmosphere and environment. Do you think this is too high a price to pay for what we call environmental protection? So what can we do? The answer lies not only in recycling, but also in reusing. First, we must reduce metal extraction and consumption from the start by adopting smarter alternative materials, designing products for longer lifespans, and implementing policies to limit new resource extraction. Graphene and carbon fiber can replace metals in many applications, reducing the demand for newly mined metals. Recycled composite plastics are now used in the aerospace industry. Boeing and Airbus have replaced aluminum with composite materials to reduce weight and improve fuel efficiency. Engineered wood is being used instead of steel in construction, with skyscrapers made of wood emerging in Northern Europe. Apple, Dell, and Fairphone are developing devices that are easier to disassemble and repair instead of being replaced entirely. Toyota is designing cars with a 50-year lifespan instead of the current 10 to 15 years. European countries are imposing high taxes on new metal extraction to encourage the use of recycled materials. China and the US have set limits on rare earth mining to protect the environment. Second, we can apply a circular economy model by extending product lifespans instead of just recycling. Fairphone, Netherlands, allows users to easily replace batteries, cameras, and screens instead of discarding entire phones. Tesla electric vehicles use modular battery packs, enabling individual part replacement instead of recycling entire lithium batteries. IKEA is testing a furniture rental model so users can return items instead of throwing them away. Michelin offers tires as a service. Users pay per kilometer driven, while Michelin maintains and replaces the tires. Tech giants like Google, Apple, and Dell are developing reuse chains for electronic components, where a processor can be reused up to 4 times before becoming waste. Third, we can extract metals from electronic waste without recycling through innovative methods. BioLeach, UK, uses bacteria to extract gold, copper, and nickel from e-waste without toxic acids. Apple's Daisy robot disassembles 200 iPhones per hour, recovering valuable metals without melting them down. Oceans contain vast amounts of gold, lithium, and copper, and Japan and South Korea are testing technology to extract metals from seawater instead of mining ore. Fourth, we must prevent metal waste at the product design stage by using easily separable alloys and strengthening the repair industry. France mandates electronics companies to provide spare parts for at least 10 years so consumers can repair rather than discard their devices. The Netherlands is developing EV repair centers where users can replace specific components instead of buying new vehicles. Fifth, we should use renewable energy to reduce recycling pollution. Hydrovolt, Norway, operates an aluminum recycling plant powered by hydropower, cutting CO2 emissions by 90% compared to traditional recycling. Japan is experimenting with cold fusion to recycle steel without generating toxic emissions. Sixth, we need policies and legislation to prevent polluting recycling practices. The EU has passed laws requiring all electronics to be repairable and have easily replaceable components. California is considering a ban on manufacturing non-repairable devices. Canada and the EU are implementing carbon taxes on newly mined metals, forcing companies to seek alternatives. European electronics companies must take back and process their products at the end of their life cycle. By shifting our focus from recycling alone to smarter resource management, we can create a truly sustainable future. Metal recycling is not a perfect solution, but it remains necessary. The key is to understand the reality and not be misled by greenwash promises. Above all, think twice before discarding metal, because reusing is always a better option than recycling. Thank you for watching the video. See you in the next one.